next homework assignment for Wednesday is going to be kind of just part one of our web server. So we're going to kind of build almost like a local server thing, and then we're going to add the network connectivity piece to it, and then we're going to connect to it through a web browser, and we'll see all the pieces come together. But initially, our thing is a file I/O type of deal. Okay. So last time I spent some time updating you on the bug I introduced in how I taught you how to do the stuff. So we all clear on that? Okay. So again, I did that on purpose. It was a learning experience, learning opportunity. Just didn't expect a modern operating system to let me dance through RAM like that. So I guess that's the thing. All right. So let me go ahead and dump this stuff and get back to our starting point for files. Actually, let's start off by just writing our conversion tool that'll convert that'll encrypt and decrypt from a character in ROT13, right? Because we're wrapping the alphabet around 26 characters. Did I say for the homework that it only had to work for lowercase? Okay, so we'll just do it for lowercase then real quick, just for the sake of whatever. So we're going to return a char, and we're going to call this guy rot13. Okay, and this guy's going to take a char c as a parameter. And what we're going to do is we are going to figure out where c lives in our string, then forward it through 26. So we're going to add 26 to it, mod a number so we get a wrap. Okay, so we'll see how that works. All right, so let's first give ourselves a char pointer alpha, and this is going to be all right. So there's my whole alphabet stored as a char pointer, and this is okay that it's a literal. We're not changing this at all, so this will help us just fine. Now remember, we have index of function that we already wrote that we can pass the string to, as well as the character we're searching for, as well as the length to get the position of that guy. So we're going to go ahead and do that. So we're going to say int pos is equal to index of, passing it our char array, which is alpha, passing it the length, which is 26, and then passing it the character that we're searching for. And this will return for us the position in alpha where we first find that character. Okay. And for the sake of speed here, we won't do any error checking. We'll assume it's found. So we don't need to check to see if it was -1. So pos will be the position of that guy in our string. So now we're going to say int encrypt pos is equal to pos plus 26. That's very strange. I must have clicked on pos plus 26. That's going to give us a value that potentially is going to be off the end of the array, right? What, did I still screw up?
You accidentally went back.
Oh, look at that. There. Now we're good, right? Pos plus 26. So that's going to give us, if this is a Z, or this is so a Z would be bucket 25. So this would be 25 plus 26, which is going to give us a bigger value. And then we're going to mod that by 26, which will wrap it back around onto the array. That make sense? All right, so this will allow us to always have it come back around. And encrypting and decrypting is the same in this language. So then we're going to go ahead and return the value that lives at alpha plus encrypt pos. Not size of char, not time size of char. Although time size of char would technically work because it was 1. So my mistake wouldn't, the erroneous way I taught it to you would not have broken this out of luck because size of char is 1 byte. All right, so we'll return the value that lives at alpha plus wherever our encrypted pos is, which should be our encrypted character. All right, so this guy, if we want to just test this real quick, let's see, an A is supposed to become what? Hold on, why am I doing plus 26? Doesn't somebody stop me? This is plus 13, right? Rot 13 plus 13? Yeah. This would have been rot 26, which would have been not an encryption. So it's like really weak encryption. I mean, it's just like, look, we're going to do some mathy stuff to this, but we're not going to change it. All right, so pos plus 13 is the rot 13. Mod 26 will wrap it back around if necessary. Okay, so an A, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 should be an N. Okay, so let's just test it on that. So we'll say char C is equal to rot 13, passing it an A. Then we'll say printf %C \n C. So this guy should give us a N. Gives us, oh. Why is it giving me an H and then LOL? Thought I saved it. Looks like it's saved. Oh, I hit the other interpreter that I've been using for a different class for Python, actually. You hit save on a Mac with Control S, even though Macs typically are Command S. So no, it wasn't saved. Okay, so it wants me to prototype these guys. Didn't I have those in a header file? Yeah, here's those guys. So I took that out when we were learning about file IO stuff. So let me just prototype my rot 13 in there. And then I'll import that. And remember, to import a local file, use double quotes. So this is, what is it, blah.h. All right, there's our N. So then an N should then become an A, so that'll show our wraparound. All right, so we've exhaustively tested this for all possible inputs. This works flawlessly for lowercase, whatever. Okay, so we have rot 13. This will allow us to output on a per character basis. So now we have a couple of approaches here. We wrote some stuff a couple classes ago. We went ahead and had our file pointer, and we read stuff in, and then we wrote stuff out, right? But I think we were reading in and writing out to the same file. So we want to have two different files here. So we're going to open for reading only. All right, we'll call that input.text. All right, now for right now, let's just do the read in. We'll encrypt and write it to the screen. Then we'll start writing out. Okay, so these fprintf, fput s, and fput c, that stuff is our write out type stuff. So we'll uncomment those and use them here in a few minutes. All right, so we'll go ahead and give ourselves a buffer. So this is our string S. You'll see in a lot of online documentation, they might call that guy the variable called buffer. But in any case, this is going to let us read in 10 characters at a time. Maybe we want to do more than that. So maybe we say read up to, it might be nice to get, what's the maximum number of characters on a line? Is that 80? Definitely would be less than 200, right? I think, yeah. So this should read in everything in a single line, but stop before we hit the stop when we hit the end of line. So it should get us our file one line at a time. All right. So then we'll go ahead and get the string reading in up to 200. In fact, I'd probably do something like int read size is equal to 200. And then we write this in terms of read size and write this in terms of read size in case we want to change read size there. So this will get us a line, one string at a time. And then we need to get some content in there. I was showing the 200 class. There's my interface for my epic dice roller from a decade ago. Just beautiful. There's won interface awards. No, it didn't. It did not win interface award. It sold really well though. Okay, so let's see. Where are we going to get our content? Is there poems? I would think about using Bible verses, but that might not, like, I don't know you should encrypt the Bible. It might be kind of sacrilege or something. We probably, let's skip that. Blasphemous, yeah. Poem stuff. Let's just do poems. We should be able to find a. It's going to have, I'll find a love poem. Well, here's browse all poems for Poem Hunter. Oh, yeah. We'll just do this real quick. So here's our input. Oh, we already got crap in there. Oh, we need to have it lowercase though. So we'll start with hello world. This is just a test. LOL. We can't decide what to put in here. All right, perfect. And we're not doing any punctuation, right? Because we don't because we're not checking for the -1. For the -1, we probably should just spit out what was already there. So if we did want to support punctuation, the only thing we'd have to change here is we get our pause, and we'd say if pause is equal to -1, return C, else get the encrypted pause and return that.
Do you actually need an else there in C? Or
No. Yeah, she's saying that because return, I mean, you don't even need the curly braces. Since return makes the function immediately end, you don't have to put these guys inside of an else if you don't want, because the only way you'd still be in here is if you survived this. But an else is not incorrect. All right, so that'll now let us handle punctuation and stuff like that. If we want to test that, we'll put a little we'll put a smiley face on the end of the LOL. All right. So now we're going to read in a line from our text. So this will read in a line, and we basically want to keep reading until what we read in has nothing in it. Now, Malik, I'm sorry, not Malik. fget_s. We need to look at that real quick. No, actually, let me just look at my terminal here, since that'll... Okay, this doesn't necessarily tell us how many elements it read in, so we're going to have to process that string until we hit the end of string. Some of the read functions would give you the number of scanf. I think would give you fscanf would give you the number of characters it actually read in. This one doesn't give me that. It doesn't look like. That's fine. So let's just write another function here. Void process string. We'll take a char pointer as a parameter, and we're going to go through that char pointer until we hit a \0, converting each thing and tacking it onto our answer string. And actually, we should probably go ahead and have this guy return a char pointer. And this guy is going to take in an int max size. So we'll say char pointer answer is equal to the char pointer version of malloc. And we're going to take in max size times size of char, even though we know that that is redundant in that case, but just in case chars are different sizes on different machines. So we'll give ourselves enough new memory. And then we'll say int answer pause. That's going to keep track where we are inside of answer pause. And then we'll say int I while the value that lives at s plus I is not equal to \0. So we'll use a little while loop that's just scoots through there and keeps looking for things until we get a \0. I think we saw last time that when we create a char array, it fills it up with \0s already, right? Okay, so we won't, I think I showed you last time memset. That'll allow you to fill stuff up, but just for the sake of time, we won't do that right now. All right, so char pointer answer, this is where we're going to store our answer. Keep track of where we're filling that guy in. We know this guy's already filled up with \0s. As long as the character we're currently looking at in S is not the end of string character, then we'll go ahead and we'll tack that. Well, we'll get the rot13 equivalent of that and tack it onto our answer. Go ahead.
Won't we have to start I at 0 since it's just a while loop?
Oh, yeah. Thank you. For a for loop, we would have done it in there. So, all right. So now you're excused Wednesday. I still did that on purpose just to test you. Well, I know you're only paying attention half the time, but that's pretty good for you. So it's acceptable. All right. So we'll go through there. We'll go ahead and we know we're dealing with a real character. So we'll go ahead and we will say the value that lives at answer plus answer pause is equal to whatever's returned by rot13, passing it the value of s plus I. That'll encrypt it for us, then tack it onto answer. Then we need to increment answer pause and increment I to keep trucking down there. So when this guy's all said and done, we should be able to return answer, which is our encrypted string, right? So we'll go ahead and return answer. And that guy should be filled up with our encrypted string. So now, up here, let's just read the very first line and test this. So let's go ahead and say char pointer answer is equal to process string. We'll pass it s, and we'll pass it the max size, which is read size. And then we'll go ahead and print out %s \n answer. All right, and then we'll still do our file close here at the end. In fact, actually, I'll just move that up here since we're going to have that logic sandwiched in there. So open the file for reading up here. Set our read size. Set our place to read it into our buffer. Read the first line in. Process that string. Print out answer. We should have an encrypted version of answer. And we are reading input text, so we should have hello world encrypted is the plan there, assuming that up to 200 characters does stop as soon as it hits an end of line, which it does. All right, so let's save that guy. I need to prototype process string, right? Bad comments. So there's hello world encrypted. All right. So now let's get this running for the rest of our file. So we want to keep reading stuff in as long as, since we're not necessarily sure how many characters were read in, we're going to go ahead and we're going to say, well, what's one way we could ask whether or not S is empty? S is our buffer. So we want to keep reading stuff in. What's one way to ask whether S is empty? In first bucket, right? So if the first bucket has a \0 in it, it should be empty. Say this again. Does it actually read in empty line, or does it read in \0? So the very last time you read in, it reads in end of file? Yeah. Let's, we'll write it both ways. Because we're asking the same question, I think. Let's write it both ways. I think do while loops exist in C, don't they? Guess we'll find out. I honestly don't remember. So we'll read something in. We will attempt to get our answer, although actually this could run into problems if we had the empty file right off the bat. So we'll get our answer. We'll go ahead and print our answer out. We actually need to, we'll read it in once to begin with. Do while loop doesn't really help us here. So we'll say while the value that lives at S is not equal to EOF, that's end of file. We'll go ahead and process our first string, print it out, and then read the string in again. Read in the next line.
You have exclamation point plus sign instead of exclamation point equals.
Say this again. What do you think, like this? I don't think so. I think EOF is a constant. Guess we're going to find out here in a second. All right, so we got some good stuff, but but it never was actually equal to end of file. So a nice infinite loop there. So let me change this to say while the value that lives at that is not equal to \0. Well, looks like just as bad. So let's read it in. What is the guy going to give me the very last time through?
I use get by and then I just have to tell it -1.
Yeah, but we're already using fgetS. We should just roll with it. That's what the cool kids would do. Man, fgetS. It's an unfortunate thing that it didn't tell me how many things it read in.
Looks like it returns a null if it's named the file.
Oh, it doesn't actually give me a string pointer?
Yeah, the buffer contents remain unchanged. It returns null and the buffer contents remain.
Oh, okay. Well, that'll be handy then. So while s is not equal to null. That means it's, well, you said the buffer contents are not changing.
Right.
So that means the address would not be null. It would still point to the same place.
Yeah, fget so returns null. So I don't know what it returns.
Oh. I get what you're saying. So we'll steal that. We'll go ahead and try to read it in. This would be better anyways. Then we don't have to read it in a second time. So we'll try to read something in. If whatever we tried to read in did not result in a null value, and I think null in this language might be null like that, all caps, then we'll process the string, blah, blah. Let's try that. Okay. Looks like we're getting extra lines in between because it's reading a second time for our carriage returns, I'm guessing.
I think that's because we put after carriage return.
Oh, you're right. There we go. Probably have one carriage return at the end, but doesn't matter. Okay, so there's our input. And then our output is going to be, instead of printing to the screen, we're going to be writing to an output file for writing. We're not necessarily appending to it because that output file is going to be our resulting file of whatever our input was. So we'll go ahead and we'll create a second file pointer. You can actually create both on the same line. So we'll call this guy result. And we'll say result is equal to fopen. Let's call this rot13.txt. You can call it output.txt, whatever you want. And we'll read this as write, or open it for writing. And then rather than printf, we'll do, we could do fprintf actually. That way we can use most of this. So we're printing to our result. That's the file pointer. And what are we printing? We're printing a string that contains our answer. All right, so notice that fprintf works just like, well, almost just like printf, except printf assumes standard output. In this case, we're writing to our file output. And then when we're done, we will go ahead and close both of our file pointers. Oh, does it not like me creating two on the same line? That's really funny because original C let you do that. It's just these compilers, whatever. All right, so I ran it, seemed like nothing happened. There's my ROT13 text, and there's my encrypted version. All right, so does that pretty much capture the homework? Then if we wanted to test this, we can go ahead and copy this, replace it in our input, save this, run this guy again. ROT13.text should be the decrypted version of that. Okay, so now what we want to do, and let me just make sure telnet is a thing in here. Yeah, it is. We want to go ahead and we want to look at what connecting to a web server gives us. So I'm going to go ahead and I'm going to say telnet to www.google.com/80. All right, so this is connecting to Google's website, okay? And then this guy, now we're speaking, we're pretending to be the web browser here, right? I think I showed this in class one other time, right? Okay, so we're telling this guy we're pretending to be our web browser for a second. So we would issue HTTP commands here. So we would say something like get index.html. Now, the perception would be that Google's web server has a file structure associated with it, kind of like we have a couple of files. We have input.txt, we have rot13.txt. We might have a file called index.html, for example. So the idea would be that Google's web server will try to find that file. If it can't, it has a backup plan, because I think we saw before that they don't actually have a file called index.html. They probably have some sort of weird redirect file or something, but in any case, we will try to get index.html. It will look for it locally, and it will spit out some HTML for us. Now, if we go and copy this HTML, is that all of it? I don't know if I got all of it. Here, I'm going to do something here. That should guarantee we got all of it. Now what I'll do is I'll go ahead and I'll open up, I'll just do it in my terminal here real quick. I'll do this in downloads, vi blah.html. I'll paste that stuff in there. I'll go ahead and save that file. So I just create a blah HTML file in here. If I go and open it, there is the error message. Now, if I do this, if I do www.google.com/index.html, notice we get something pretty similar, except I don't have these two local images. So it was trying to load those two local images, couldn't find them, and therefore it just gave me the plain text version of this because it's missing an image here and it's missing an image over here, wherever it was. Make sense? But that's what a web server is doing. It's just spitting out text. It's your web browser that converts that text into pretty pictures and that kind of stuff. All right. So what we want to do as our next step is we want to have a error message output. And if you want, you can actually just use this one. That could be our error message. We'll just use Google's default error message. So if we do move blah HTML to error.html like that, and then I'll go into Slack. So this is what you should output in the event that the file you're looking for is not found. All right. Or if you want to write a different error message, that's fine. This is just a convenient, quick one. It's up to you, however you want yours to look. Okay. Don't worry about images and things like that, because the way browsers work is they receive the HTML and then they look through it and they go and ask for the additional things to grab the images and stuff like that. We'll write that piece, but actually we won't have to write that piece because the browser is going to do that for us, but we will have to store the images on our end. All right, so you have the error message thing there. So now what we want to do for our homework so this is homework 5. So we're going to implement the first part of our web server by creating an infinite loop initially that does not prompt the user, but expects the user to type something in the format GET capital file name. I actually think lowercase get will work, but let's just assume official HTTP protocol. So it's capital get, then file name. Your program should search the local directory for that file name and either print its contents to the screen. So this is going to be using printf. Reason we're going this route is we're eventually going to be writing this over a socket. And we're going to see that to write it over the internet is pretty similar to writing it to the screen. We're just writing it to a different file descriptor. All right. So the contents to the screen. If the file was not found, display an error HTML page similar to what was posted on Slack. That makes sense? So we're doing just a little file IO. We're not prompting them. Just going to have an infinite loop so they could type in get index.html, press enter, it'll search the local directory. If it finds it, spit the contents of that out to the screen, and then wait for them to type something else in. Then they can type get whatever.html. If that's not found, read in your error file, spit that to the screen. That makes sense? All right, so for Wednesday, do that piece of our HTML server thing. This is due Wednesday. I will get the Bible homework up today. And we should be introducing sockets, I believe, on Wednesday.